Have you ever stared at a math problem, one of those how many ways can you questions, and just felt your brain totally freeze up? Yeah, you are not alone. But stick with me, because in the next few minutes, we're going to crack this code together. We're going to make counting, permutations, and combinations make perfect sense. Let's get into it.
You know, it all starts with a simple question from the real world. Think about your phone or your bank card. Have you ever wondered how many possible 5-digit pins there are? This isn't just some random textbook problem. It's a puzzle that uses the exact same principles we're going to cover right now.
So here's our game plan. We're going to start with the basics in counting your world, which is really all about one simple but super powerful multiplication rule. Then we'll dive into the big divide, what happens when order is everything versus when order doesn't matter. And to wrap it all up, we'll build a final exam checklist so you can walk into your next test feeling confident. All right, section 1, counting your world. And trust me, you're going to be surprised how often you already use this kind of thinking without even realizing it. Okay, this right here, this is the engine behind absolutely everything we're about to talk about. It's called the fundamental counting principle. It sounds superficial, but the idea is actually really simple. If you've got a certain number of choices for one thing and a certain number of choices for a second thing, you just multiply them together to find out the total number of possibilities. That's it. Let's make this super real. Meet Jeremy. He wants to order a lunch combo with 1 slice of pizza, 1 side, and 1 drink. Now, how many different meals could he possibly create? You could try to list them all out, but man, who has time for that? There's a much faster way.
Let's just break it down. We can see he has 4 choices for pizza. Now, for each of those 4 pizza choices, he has 2 choices for a side. And then for each of those pairings, he has 3 choices for a drink. You see how the options just branch out and multiply? That's our huge clue right there.
So you just do the math. 4 times 2 times 3 is 24. Boom! Just like that, Jeremy has 24 different lunch combos to choose from. Way faster than writing them all down, right? Okay, this brings us to what I think is the single most important question you will ever ask when you're solving these problems. Does the order that you choose things in actually matter? The answer to this one question is going to send us down one of 2 very different paths. Just think about it like this. In a race, finishing first is totally different from finishing second, which is different from finishing third. The order is literally everything. That's a permutation. But what about pizza toppings? Does it matter if you ask for pepperoni then mushrooms or mushrooms then pepperoni? Nah, it's the same pizza. The order doesn't matter, and that's a combination.
All right, section 2. Let's head down that first path, when order is everything. This is where we talk about permutations.
So what is a permutation exactly? It's just a fancy word for an arrangement where the order is absolutely critical. If you swap the same items around, you create a brand new, totally distinct outcome.
Imagine you're electing a president and a vice president from 5 people. If person A is president and person B is VP, that's completely different from person B being president and person A being VP, right? The roles, the titles, they matter. And because that order matters, it creates way more possible outcomes.
Here's another quick one to lock it in. You have 7 swimmers in a race. First gets gold, second gets silver, third gets bronze. Is the order they finish important? Oh yeah, it's the entire point of the race. That's a classic permutation problem. Okay, so now let's go down that other path. Section 3, when order doesn't matter. Welcome to the wonderful and slightly simpler world of combinations. A combination is just a selection of items. Think of it like a group where the order is totally irrelevant. It's like picking a team for a project. If you rearrange the names of the people on the team, it's still the same team, right?
Let's go back to our same 5 people, A, B, C, D, and E. But this time, instead of president and VP, we're just picking a simple 2-person committee. So, is a committee of A and B any different from a committee of B and A? Nope. It's the exact same 2 people. And that's why the list of possible combinations is so much shorter than the list of permutations.
To put it as plainly as possible, with combinations, shuffling the items you've picked doesn't create a new outcome. They're all just considered the same group.
And that brings us to my favorite part, Section 4, your final exam checklist. This is where we put it all together into a simple tool you can actually use. Okay, here is your process for every single one of these problems. Step 1, just read the problem carefully. What is actually being chosen? Step 2, ask the golden question. Does the order matter? Step 3, if your answer is yes, it is a permutation. Step 4, if your answer is no, it's a combination. And please, Remember the huge pitfall here. For sequential choices, like getting a pizza and a side, you always multiply. That's our fundamental counting principle coming back to save the day.
So to wrap things up, I've got a final challenge for you. Now that you know the rules of the game, how many unique ways can you arrange the letters in the word explainer? Think about the process we just covered. Ask yourself that one big question. Does the order of the letters matter here? Give it a try. You've totally got